Record. Classify as true or false. 3 divides 12 is true because 12 divided by 3 gives you a remainder of 0. Notice that that symbol is a vertical bar. It's not a division symbol, a fraction symbol. B, 0 divides 2 is false because that would imply that you would be dividing 2 by 0, but we can never divide by 0. C has a question mark because we don't have a vertical bar. Instead it says it's even, so we have to think of what even means. Even means it can be divided by 2 evenly. It gives a remainder of 0. So 0 is even, since 0 can be divided by 2 and have a remainder of 0. D, we have 8 divides 2, which is false because it implies that 2 divided by 8 does not give a remainder 0, so 8 does not divide 2. Prime factorization is about breaking a number into a multiplication of prime numbers. Only prime numbers can be used in the multiplication. Notice we have 2 cases. Both of them are 30. One starts with 2 times 15 is 30. The other one was 3 times 10 is 30. Even though we start differently, we end up in the same place. At the end, 30 can be represented as 2 times 3 times 5. And we say prime factorization because it's only prime numbers that are being multiplied. This is a challenging problem because the base, which is 210, is a big number. So what you do is you concentrate on that base at 210 and start working with that number. 210 is the same thing as 21 times 10. Now, think of the 21, that is 3 times 7, and then think of the 10, and that's 2 times 5. So 3 times 7 times 2 times 5 is 210. Now distribute the power of 10 over the prime numbers. And you notice the prime factorization, our numbers are being multiplied, where the numbers that are being multiplied are prime. This one is asking us, find the number of divisors. In other words, all the numbers that can divide another number evenly. The first step is to find the prime factorization of the number you're considering. The second step, write the prime factorization in exponential form, which means the prime number to some power. 3 is identify the power of each prime. If you look at 4, it says apply this rule. The power of P is M, the power of Q is N. And this formula, this rule tells us that if you get a hold of those powers and add a 1 to each of them and then multiply the results, that'll tell you how many divisors the original number had. So whatever number is 2 to the 3rd times 5 to the 2nd, that number has 12 divisors. It has 12 numbers that can divide it and give you a remainder of 0. Prime numbers have only 2 unique, in other words, different divisors. For example, 2 is a prime number because the only 2 numbers that can divide 2 evenly are 2 and 1. What stands out here is that the numbers have to be different. That's why 1 is not considered a prime number, because 1 can be divided by 1, and then 1 is 1 again. So it's the 2 numbers are 1, it has to be 2 different numbers. So 1 is disqualified from being a prime number. The first prime number is 2, and by the way, it's the only even prime number out there. Example, the next example, 6 is not prime. And if a number is not prime, it's composite. It's one or the other, it can't be both. And 6 is not prime because we have 1, 2, 3, and 6 able to divide 6. If 6 was only able to divide by 2 numbers, then it would be prime, but we could divide 6 by 4 different numbers. Notice 6 has 4 divisors, not 2. That's why it's not prime. Determine whether a number is a prime. That's one of the very important questions. To do that, you would have to check to see if there's a number out there other than 1 in itself that can be able to divide that number. The list would be very big. So in order to cut that list down, we use the formula, the one that's circled. P is less than or equal to the square root of n. And this will cut the list down of the numbers you have to consider. How do we use this formula? P is less than or equal to the square root of n. First, identify who the n is, and then identify who the p is going to be. The n represents the number you're trying to determine whether it is a prime. And p is going to represent the list of prime numbers you would need to use to check whether that n is a prime number. In this example 11, they're asking us whether 397 is composite or prime. Remember, it has to be one or the other. So first, identify who the n's going to be. Well, that's the number you're considering, 397. Now stick that 397 in the formula. Notice how it replaces the n. Now we have p is less than or equal to the square root of 397. Get your calculator and you're going to get an approximation of 19.9 for the square root of 397. So that p is going to be the list of numbers up to 19. Notice we don't take 19.9. It has to be a whole number. And 19 is the last prime you have to consider. So P would be the list 2, 3, 5, 7, 11, 13, 17, and 19. This problem continues. If 397 is divided by each number in the list and none give a remainder of 0, then 397 is a prime. None of those numbers in the list were able to divide 397. If they were, then we would say this number has more than two numbers that can be multiplied to make it. And there was no number in the list, so the only two numbers that divide 397 are 397 and 1, two distinct numbers. 397 is prime, therefore.